Determine the decimal equivalent of each of the following numbers. We have Roman 1, 756 base 8, and we have 89.4 base 16. So we are told to convert these two to decimal. Decimal is base 10, and base 10 are the normal numbers that we normally deal with in everyday life. So in our daily basis, we normally deal with base 10 numbers. But we have the other systems because of data representation in computer systems. So in this case, what you should know is from any base to base 10, from any base to base 10, we use the powers method. Or else we can correctly call it the polynomial method. So I'll show you how this comes in. For example, let's start with Roman 1, then the rest I'll explain. Let's do Roman 1. For example, here we are having 756 base 8, and we are supposed to change to base 10. And I have said from any base to base 10, we use the powers method or the polynomial. This is what I mean by the powers method. If it is a whole number, for example, this is a whole number, we have no decimal points. You have to indicate the positional powers of every digit. So you count from right to left. So at this point where we have 6, we have 0, you count from 0, then we follow with 1, 2, and so on. So what you do, you take the particular digit, you multiply by whatever base which is here, the power that you have indicated above the digit. At this case now it is power 2. So 8 is the base, and then the power which is for that particular digit. Then you add this to every other digit. So 5, 8 will be power 1. Then we have 6, 8 will be power 0. So when you compute this, you'll get 448 plus 40 plus any number power 0 is 1, so this is 6. When you add this, you'll get 494, and this is base 10. Before we can go to the next question, which is Roman 2, let's say it was binary. We could have written like this. For example, if it is 100 and 001, you count from right to left. So at this point we have this is base 2. So you count the powers. We have 0, we have 1, 2, 3, 4. So you'll be taking the digit at this particular point is 1, where we have 4, and you multiply with the 2, which is the base, power 4, and you add the next, which is 0 times 2, power 3. Next, which is 0 times 2, power 2. Next, which is 0 times 2, power 1. And then you add lastly 1 times 2 power 0. Because I have said from any base to base 10 you use the powers. This is how the powers is applied. So when you do this, the first one is 16, 2 power 4. The rest we shall have 0, 0, 0, and the last one is 1, and this is 17. So this is 17 base 10. When you change 17 base 10 to binary, you'll get the number here. So let's go to Roman 2. This is base 16, which is 89.4. This is base 16. Very important, another point you have to note, as you can see here, we have a whole number and we have a decimal point number. What you should know is that wherever you find a decimal point number, be it in octo, base 8 or base 2, you apply the same methodology, but in this case now, for the whole number, you start from you start counting immediately after the decimal point from right to left. So here we shall start from where 9 is, and for the decimal part, you normally start with power negative 1, and you start from where we have immediately from the decimal point, you start at that first digit towards the right, and you start with the power negative 1, not 0. So for example, in this one, 9 at this point we indicate 0, and 8 will be 1, and 4 will be power negative 1. If we could have another digit, it will be power negative 2, and so on. So for this whole part, this whole number, we shall apply the same method that we have seen for the other bases, and here we shall also do the same, but the power, the negative power, we shall see how it is manipulated. So in this case, our 8 will be multiplied by 16, and at this point 16 is power 1. We add 9 times 16 power 0. Then this is point, and we shall take our 4 times 16 power negative 1. Remember, 16 is the base. Now in this case, now we do our calculations. 8 times 16 power 1, we get 128. 16 power 0 is 1, so we have plus 9 here. Then we have point. In order to remove this power of a negative, we write 4 times, you take the reciprocal. So it will be 1 over 16. If it were, for example, if we could have, for example, let's say we add, for example, 2 here, so which will be now power negative 2. We could have now 2 times 16 power negative 2. So to remove the negative power, we say 2 times 1 over 16 squared, and we manipulate that. So in this case now we shall have, this is the same as 4 over 16. We can cancel to have 1, and here we have 4, so that is a quarter. So we add 128 plus 9, we normally get 137, and 137 point, a quarter into decimal is 0.25. So we add 0.25 and we get 137.25, and this is base 10. So you have to look at more questions, more so the ones having decimal points, so that you are able to get the concept well.